So this is section 5.5, applying other rules for exponents. And so we're looking at quotients and negative exponents. So we're looking at quotients. And negative exponents. So here is the first rule. The first rule is if you have 1 over a to the negative n, it's the same thing as a to the n. So basically that negative is forcing you to take it and move it to the numerator. Okay. The second rule is if you have a to the negative n all over b to the, let's say, negative m, then we would move this exponent base to the numerator and this base negative exponent to the denominator. So that would be b to the m over a to the m. So this goes here and this goes here. So number 3, we have a over b to the negative n. That's just telling you that this negative n goes to both, and it's just like number 2. So we would switch it to b over a to the n. And these are the last 3 rules that we are talking about. So if we take a look at an example, okay, if we have 1 over 2 to the negative 5, okay, then that's the same thing as taking all of this and moving it to the numerator, so that becomes 2 to the 5th. And so then, of course, 2 to the 5th is 2 times 2 times 2 times 2 times 2, and this is 2, that's 4, this is 4, this is 16, and then 16 times 2 is 32. So another problem would be 3 to the negative 2 all divided by 4 to the negative 2. So that means this gets moved to the numerator and all of this gets moved to the denominator. So that's 4 squared all divided by 3 squared. So that would be 16 over 9. So 16 ninths is what that would be. Oh, I take that back. Yeah, 16 ninths. Alright, and then let's take a look at another problem with some variables in it. 5x, and x is to the negative 4th power. And then we have y to the 2nd. And then we have 10x, and x is squared, no negative. And then y to the negative 4. Okay, so let's just move the negative exponents with their base before we do anything. So that's 5 y squared. This y comes up, so that's y to the 4th. The 10's down here. We have x squared, and then this x to the negative 4 goes to the bottom. So now I can combine it. And I know 5 divides into 10, so this is really a half. So now I have y to the 6th divided by 2, and this is x to the 6th. Okay, and that's how C is. This problem's done. Okay, the last one is we'll do is D, and we'll move the screen up a little bit so you can see it. Okay. Alright, so we have this problem where it's 2 divided by z to the 2nd. Okay, and that's all to the power of negative 4. So that just means we switch things. The 2 goes down to the denominator, and the z squared goes to the numerator. So that's z squared over 2 and that's to the 4th. Okay, and now this 4 gets multiplied to both places. So this is z to the 8th, and then this is 2 to the 4th. And 2 to the 4th is 16. So I'll put it over here. Now I'm out of room here. So z to the 8th over 16. And so here's a few examples of where these other properties come into play and how you simplify your expression down to a more simpler form and have no negatives as exponents.